All right, so inequalities. An inequality is just like an equation, except instead of having two expressions that are connected by an equal sign, they're connected by a less than sign, a greater than sign, a less than or equal to, a greater than or equal to sign. Okay, so examples of inequalities would be something like x is less than y, x is greater than or equal to 3y, x is less than or equal to 15, x minus 7 is greater than y. Okay, so the two things that we want to notice about inequalities is, first of all, they have a direction. That's the thing that makes them different from equal signs, and that's the thing that can cause complications downstream that we're going to talk about in this video. Okay, so the direction of the inequality is indicated by a small side and a big side. Okay, so the small side here means that x is the smaller thing, and the big side, the open side, is the side that's greater. The other thing about inequalities is sometimes they are strong and sometimes they are weak. Sometimes they include the endpoint and sometimes they don't. Okay, so this would be the second one here. X is greater than or equal to 3y. That would be a weak inequality. We could say x is weakly greater than 3y. Probably most of the time we would just say x is greater than or equal to 3y. So sometimes inequalities include the possibility that the two sides are equal, and we denote that by having the bar underneath the inequality, and sometimes they don't. Okay, so these top and bottom inequalities are strict inequalities, and this is, in this case, we would say x is strictly less than y. Okay, so the case where x and y were equal would not be consistent with the claim that x is less than y, but it would be consistent with the claim x is less than or equal to y. Nothing hard or non-obvious there. When we're doing algebra with inequalities, all those basic rules of algebra apply. We can use distributive, commutative, additive properties. We can factor things. We can multiply by 1. We can add 0. And we can multiply both sides of an inequality by the same number or divide. But here's where the one tricky thing comes in. It is the only tricky thing about inequalities, but it ends up being tricky in lots of places. So that's why we're going to pay some attention to it right now. Okay, so this key issue with inequalities. If you multiply both sides of an inequality by a negative number, you switch its direction. Okay, so if we start off here with x less than y, and I want to, for some reason, say I want to multiply through by -1. So I'm going to say -1 times x and -1 times y here. I'm actually switching the direction. Okay. So by switching the direction, I mean we're taking a less than and turning it into a greater than here, or vice versa. Same would apply if they were weak inequalities. All right. So let's wrap our brains around that. Like always, it's easier to see how these things work if we put numbers in there. So if we just start off with something that I think we're all okay with, the claim that 2 is less than 3, and we multiply through that by -1 so that we get -2 and -3. Well, indeed, -2 is greater than -3. And a good way to see that is to think about a number line. Okay? So if you find yourself working these problems and things start to get a little bit out of focus, it's never a bad idea to try drawing a number line. We've got 0 here, And that initial claim that we had that 2 is less than 3, what are we really saying there? We're saying that positive 2 is less than positive 3. We're saying that 2 is closer to 0. The negative numbers, if you think about them in terms of distance from 0, the same thing is still going to be true. So when we're multiplying through by that negative number, we're flipping everything over to the other side of 0, and we're going to get a mirror image there. Okay, so multiplying 2 by -1 gets us to -2. Multiplying 3 by -1 gets us to -3. Okay, so indeed here we have 2 is less than 3, but -2 is greater than 3. It's greater than 3. Fix that quick. Greater than -3. Okay. In saying -2 is greater than -3, just really belaboring this point because it's easy to see with numbers and it gets harder to see with variables. But in saying that -2 is greater than -3, all I'm saying is that -2 is farther to the right on the number line. That's what being greater than means. And being less than means being to the left on the number line. Okay. And you can, I think, pretty easily see that we could pick any numbers we wanted here. We could pick any x, any y. And if we start with x being less than y, it's always going to be true that -x, this mirror image, is going to be greater than -y. Okay. So getting used to this idea that when we multiply by a negative number here, I've been using -1, but it could be -5, it could be -1/5, it could be any negative number, that whenever we do that, we switch the direction of the inequality. So that, as I want to keep emphasizing, that is the only tricky thing about inequalities, but it comes up over and over again, and it's an easy thing to miss. So I want to end this kind of basic video with a simple example of dividing through by a number that's obviously negative. And then in the next video, we'll go through some more complicated examples. So just sort of a quick example to finish this point up. Let's start with claim -2x minus 3 greater than or equal to 5 here. Okay, and so I'm going to solve that for x the way we would if it was an equation. And what am I going to do? Well, the first thing I think I'm going to do is I'm going to take that 3 over to the other side, meaning I'm going to add 3 to both sides. So, rules of algebra, I can do it to an inequality just like I can do it to an equation. So I get -2x is greater than or equal to 8. Added 3 to both sides. Now I want to divide both sides by -2 so that I get the x by itself. Okay, so here's the step where I'm going to divide by -2, and that means I have to switch the direction so that the greater than or equal to becomes a less than or equal to. So telling myself that's what I got to do, that's what I've got to do. Dividing through by -2, I get x. Switching the direction here, x is less than or equal to -4. Okay, and that is indeed the solution. So this is easy, relatively easy to remember to do when the number that we're dividing by is the number with a specific value, -2. Oh yes, very easy to see that it is less than 0. It gets trickier when you're dividing by variables that could be positive or could be negative. So that's going to be one thing that we're going to look at in the examples video. The final thing I want to point out here is that when we solve an inequality, we get a range of values. When we solve an equation, we usually get x equals one specific thing. because equations are really specific things. Something is exactly equal to something else. Inequalities are more general things. We're not saying what exactly x is equal to. We're just saying it's less than a certain thing. It's greater than or equal to another thing. So the final thing to observe here is that the solutions to inequalities are usually ranges, okay? So not just one particular value for x, any value of x that would be less than or equal to -4 would make this first inequality true. Final thing I'll do, I think this is the third time I've said that I'm going to do a final thing, but this I think really is the final thing I'm going to do in this video, is let's just check. Let's just check to see if this claimed solution that x less than or equal to -4 is the solution for the equation that we started with. And all I'm going to do is I'm going to pick values for x that are, I'll pick one that is indeed less than -4, and I'll pick one that's greater than or equal to -4, and or one that's strictly greater than. And it should be true for the one that is less than or equal to -4. It should be false for the other one. So if we have x equals -5, x equals -5, -5 is less than or equal to -4, the inequality should be true. And let's just substitute that in. So -2 times -5 minus 3 is greater than or equal to 5. Well, -2 times -5, it's a negative times a negative, so we get a positive 10 minus 3, that equals 7, and that is indeed greater than or equal to 5. So that looks good. What if we picked x equals -3? -3 is not less than or equal to -4. -3 is actually greater than -4. So the equation we started, the inequality we started with should not hold for x equals 3. And let's check. For x equals 3, -2, -3, -2 times -3 minus 3 greater than or equal to 5. That is positive 6. The negative times the negative gives a positive 6 minus 3. That is a 3. Is that greater than or equal to 5? No, it is not. Okay, so that checks too. So in checking to see whether the claimed solution is consistent, the standard thing to do is to pick a value that a value for x that the inequality says should be consistent with the expression, with the inequality we started with, and one that it shouldn't, and make sure that it does what we expect it to. Okay, so next video does have two slightly more complicated examples where we're having to think about multiplying or dividing by expressions that can take both positive and negative numbers, and we'll approach that in the way that we often do with math. We'll just consider the cases separately. So see you then.